Okay, let us see another example about the cause of interception and collision. Don't confuse this with the cause of closest approach. No, this is just the cause for interception or collision. So at 9 a.m., two ships A and B are 115 kilometers apart, with B on a bearing of 270 from A. So instead they're telling us that B is on a bearing of 270 from A. So meaning we start with A. So if I'm starting with A, this is my A. This is my A. We know that this is going to be R270. This is the 270 from here, 90, 80 to 70 from A. So meaning this one from here to here. That is our 270 from A. So meaning this one is this side like that. Okay, so if that is the case, then where I stop, I can put my B. The distance is 15 kilometers. Okay, and then they're telling me that ship A moves at 5 kilometers on a bearing of 330. So 330 means that it's going to be here. 330. So 330 is going to be there. So 330 means that I'll be on a having 30 degrees to reach there. So okay, that's it. Then, and also B has a maximum speed of 10 kilometers per hour. Find the direction of B must set in order to intercept A. If you need to intercept this, it means that you see the direction where this one is going. It means it's going to set off from there. So meaning, because of the interception, we shall set it like this. We can call this alpha, and then we can call this theta. So this is the cause of interception, alpha. Alpha is the cause of interception. So this is our north. But this one is moving at B has a maximum speed of 10 kilometers per hour, and this one is moving at 5 kilometers per hour. It means that if they are going to intersect, it means that now our resultant velocity, AVB, is going to be parallel to their initial displacement. So, how do we get this? Because they want us to get this alpha. So you see, if I have this theta, I can every get this. So, remember, if this is 30, this one is going to be 60 degrees. And so, if this is theta, and this is 60 degrees, it means that the angle sum of a triangle add up to what? Add up to 180. So if we have 60 already, it means that this is theta. So meaning the balance is 120. So if this is theta, then this is going to be 120 minus theta. As simple as that. So there are two ways you can use it. Either you use sine rule to get this theta, because you have this and this. So let us say using sine rule, we want to get theta. So we are going to say this over this. So 10 over sine 60 is going to be equaling to 10 over sine 60 is going to be equaling 5 over sine theta. And from there, you can every cross multiply and set our theta. From there, get the answer. You get this times this divided by that, then you get the inverse. Don't show us the what. So this is going to be 25.66 degrees. So this is going to be our. So now we need this cos. So it means that now our alpha is going to be 90 minus theta. So our alpha is going to be now 90 minus 25.66. And so our alpha degrees. Or you can give as north. You see from the north, this is our alpha, 64.34 degrees towards the east. As simple as that. So this is the cos, but we should say it as simple as that. I'm going to show you another method. Then part B, they want us to get the time. They want us to get the time. They want us to get this time. I know that always our t is equal to their initial distance between the two over the relative velocity. Okay, how are we going to get our relative velocity? From here, okay, allow me to leave this one and I write it here. Okay, or north once they are east. So you can see that now. First of all, I need this AB. I need this AB. I have the angle opposite. I have this and this. So still using sine rule. So we are going to say 10 over sine 60 is going to be equal to this 10 over sine of the opposite angle is going to be equal to this AB. Now we need FD, relative velocity. That's why I'm using velocities over then sine of 120 minus our theta, which is 25.66. So I can aggregate every by possible time here. So 120 my LV here, they are giving me 11.5139 meters per. They are in kilometers per hour. So this is my LV. So meaning from there, my T is going to be, which is LV, which is now 15 over 11.5139. So from here, my T is going to be 1.3028 hours. As simple as that. So that's the time. Alternatively, we know that for interception, for collision, for interception, relative velocity, I mean the displacement of at any time, it will be equal to the displacement B at any time. So we need to get this. This is given by RA initial plus velocity of A times T. It should be equal to R of B initially plus R velocity of B then times T. So there we need to get those two. So here you see this one is going to be 0, 0, and this one is going to be from, if this is 0, 0, then this is going to be 15, 0, because we are just changing the displacement. So this one here, from this one we are going to call it our RA, we are going to call it 15, 0, then plus the velocity of A. You see we can easily get this. It's like the horizontal component. We are going to resolve it. If we resolve it in this format, if we resolve A, I think you see if we resolve it, we are going to be having something like that. If we have to resolve this 5 like that, so this one is going to be 5 30 sine 30. This is our 30, so this is adjacent, so cos 30. This is going to be 5 sine 30 because it's opposite. I think you can see. So now add the rest of A like this, then like this. So this is going to be the opposite. So the horizontal is negative 5 sin 30, and this is going to be 5 cos 30 times t equaling to r is going to be 0, 0, the initial displacement of A. From here it's 0, 0. Then plus the velocity of B. How are we getting the velocity of B? The velocity of B, now here we assume that we don't know it. Okay, so to simplify this, now to resolve this, we are going to be having, see if we have to resolve this. I have here 10, I have theta. Remember, I don't know theta for now because this is an alternative. So this is going to be 10 cos theta, and this is going to be 10 sin theta. So I put them here. The horizontal, you see it's going in this direction. You see the direction in which it's going. The horizontal component, then the vertical component. So my horizontal is going in this direction. So I'll be having 10 cos theta. Then this one, you see the vertical component is 10 sin theta with is. Okay, so from there you can see we have 15, then minus, this is 2.5 t, then this will be 5 root 3 over 2. If we put in this equaling to 10 cos theta, 10 sin theta, sorry, that is t. T sin theta times t. So what does it mean? It means that this is equal to this. This is having t. This is equal to this, and this is equal to that. So it implies that now 15 minus 2.5 t is equal to 10 cos theta times t. Okay, this is equation 1. Then also here, 5 root 3 over 2t is equal to 10 sin theta times t. So you can, every step you can cancel this out, and then this out. Then you can divide. So our theta from there, and it's going to be sin inverse of 5 root 3 over 2 divided by 10. So our theta from there is going to be I think you see it's giving us 25.66 degrees. And if you have this, you can come and put it here and get your t. Then after getting t, you can aggregate the rest. So that's it. You put use 1 to get t and proceed. So if you have theta, you can just get t. And then if this is our theta, then you can get our cos. So from there, our alpha will be, you get this minus 64.34 degrees, the cos. That should be set. Then use this, put this here. Then we put this here, you'll be having our time. If you put this here, you can aggregate our time. So that's it. Those are the 2 ways you can use. I wish you well.